Let's proceed now. Permutation. So what is permutation? So permutation, consider that the possible arrangement of the letters A, B, and C. The possible arrangements are ABC, ACB, BAC, BCA, CAB, then CBA. So in short, okay, in other words, when we say permutation, order is important. Okay, order is important when we talk about permutation. If the order of the arrangement is important, then we say that each arrangement is a permutation of the 3 letters. Thus, there are 6 permutations of the 3 letters. Again, when we say permutation, the order of arrangement is important. Okay? The order of arrangement is important. So, to start with, I'm gonna stop sharing because I'm gonna use my whiteboard this time. So, let's proceed now. So, we will be discussing permutation. So let's proceed now to the first rule of permutation. So rule number 1, under permutation. Okay? Again, when we say permutation, arrangement is important. Order of arrangement is important. Okay? Let's start with the first rule. So permutation, can you see my whiteboard?
Yes, ma'am.
Permutation of n things taken n at a time. Okay? Or we call it row permutation. Okay, that's the first rule. Row permutation. Okay, permutation of n things taken n at a time. So that is row permutation. So for example, the number of permutation of n distinct objects is n factorial. So the factorial notation simplifies the counting task of finding the number of possible arrangement of n distinct objects. So for example, in how many ways can 2 parents and 3 children be arranged in a line for a family picture? Okay. In how many ways can 2 parents and 3 children be arranged in a line for a family picture? So how do we answer that? First and foremost, you need to determine how many people are there. How many? Ilan ba? How many people? There are? Yes? 5. So there are 5. Okay? So when we're talking about permutation, we need to use the factorial notation. And that is n factorial. Okay? N factorial. So there are 5 persons. Okay? There are 5 persons. Okay? So arrange in a line for a family picture. So there are 5. So person A, B, C, D, E. So there are 5. So meaning, and how many ways can 2 parents and 3 children? So that would be 5 factorial. So what is 5 factorial? So what is 5 factorial? What is 5 factorial? What is 5 factorial? You can use the calculator. What is 5 factorial?
120.
Okay, 120. So you do have 120 ways. Okay? 120 ways. 120 ways. In how many ways can 2? In how many ways can 2 parents and 3 children be arranged in a line for a family picture? In how many ways can 2 parents and 3 children be arranged in a line for a family picture? So you do have 120 ways. Okay? Another example. Let's say the given is, in how many ways can 6 students line up if, okay, there's a condition. First condition, 2 students want to stand next to each other. Okay? In how many ways can 6 students line up if 2 students want to stand next to each other? So how do we answer that one? Using the row permutation. So there are 6 students. So student 1, student 2, the 3rd student, 4th student, 5th, and then 6th student. Okay? So 1, 2, 3, 4, 5, 6. Now, there's a condition. What's the condition? 2 students want to stand next to each other. Let's say, student 3 and 4 They want to stand next to each other. Okay? They want to stand next to each other. Student 3 and 4. If that is the case, you will take it as 1. Okay? You will take it as 1. So therefore, ilan na lang? If you will take it,
5.
okay, 5. So we have 5 factorial. Okay? So there are 5 you can arrange. There are 5 person or students that you can arrange. Student 1, student 2, 3 and 4, you will take it as 1. Why is it? Because they want to stand next to each other. So you will take it as 1. Okay? Third arrangement, fourth, and then fifth arrangement. So you have 5 factorial. Now, we need to multiply it by 2 factorial. Why is it? Why is it? Why is it we need to multiply by 2 factorial?
So that 3 and 4 can switch places.
Okay, because student 3 and 4 can switch places. You can arrange it also. So therefore, what is the answer?
240.
Okay, 240 ways. Next condition. 2 students refuse to stand next to each other. Okay? 2 students refuse to stand next to each other. So how do we do that? 2 students refuse to stand next to each other. How do we do that? There are 6 students. 6 students. Okay? There are 6 students. But the condition is 2 students refuse to stand next to each other. How do we solve that? To solve that, since there are 6 students, so we have 6 factorial minus, okay, minus to the student, okay, to the 2 student, 1 to stand next to each other. Okay? You need to subtract it to the students, to the 2 students, 1 to stand next to each other. So that will be 6 factorial minus 5 factorial multiplied by 2 factorial. Okay? So that will be 720 minus 240. So what will be the answer? What will be the answer? 720 minus 240. So what will be the answer?
480.
Okay, 480. 480. Okay? So again, how do we solve this condition? 2 students refuse to stand next to each other. So the total students that we have, which is 6. So 6 factorial minus the number of the 2 students want to stand next to each other. So that will be 6 factorial minus 240. So 720 minus 240, so you have 480 ways. Okay? So that is row permutation. Another example. In a school presentation, 3 boys and 3 girls decided to arrange themselves on the stage. So first condition, in how many ways can they arrange themselves in a row if boys and girls alternate? Okay, so the first condition. In a school presentation, 3 boys and 3 girls decided to arrange themselves on the stage. The condition, in how many ways can they arrange themselves in a row if boys and girls are alternate? Okay, so how do we answer this? How do we answer this one? Alternate. So we have 3 boys and then 3 girls. So we have, if, let's say, for example, the first one is girl, and then we have boy, girl, boy, what? Girl, boy, and then, is it already 6? Is it? Girl, boy, girl, boy, girl, boy. So how do we answer this one? In how many ways can they arrange themselves in a row if boys and girls alternate? Okay, so for the girls, you can arrange them in how many ways? We're talking about girls. Ilan? Yung girls, you can switch it how many times? So that would be 3 factorial for the girls. And then you can switch also the 3 boys. So you do have 3 factorial. Multiply it by 2. Why is it 2? Why do we need to multiply it by 2? Why do we need to multiply by 2? Why do we need to multiply by 2? Or 6 factorial multiplied by 2, they are the same. Why do we need to multiply by 2?
There are two arrangements.
Why do we need to multiply by 2? The answer is 72 ways, am I right? 72 ways. The answer is 72 ways, am I right? Is it 72 ways? Is it?
Yes po.
So why do we need to multiply by 2? Why do we need to multiply by 2, people? Why do we need to multiply by 2? 72 ways. Why? Why is it?
They can be arranged two arrangements.
Sorry?
There are two possible arrangements.
Okay. Kasi pwedeng boy, girl, boy, girl, boy, girl. Okay? Pwede yung isa, mauna si boy. Okay? That's why we need to multiply by 2. Okay? 3 factorial times, multiply by 3 factorial times 2. Or 6 factorial because there are 6 students, multiply by 2. So you do have 72 ways. Okay? 72 ways. So can be 6 factorial, multiply by 2. Okay? Pwedeng interchange. Okay? Pwedeng si girl na nauna kanina, and then this one is boys. So you do have 2 arrangement. Okay? Or it can be, you arrange the girls, so that will be 3 factorial, multiply by 3 factorial, and then multiply by 2. So you do have 72. Okay? Next. Next. In how many ways can they arrange, okay, next condition, themselves in a row if all the 3 girls stand together and all 3 boys stand together? What about this one? In how many ways can they arrange themselves in a row if all the 3 girls, so 3 girls down, 3 girls stand together and then 3 boys? So how do we answer this one? How do we answer this? How do we answer this? The answer is 72. But the question is, how do you get 72? 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 To get the 72, so we can arrange the 3 girls in how many ways? That is 3 factorial. You can switch the 3 girls in how many ways? 3 factorial. Next, what about the boys? You can switch or you can arrange the boys in how many ways? 3 factorial also. Okay? But the condition says, girls, 3 girls stand together and all the 3 boys stand together. Okay? They need to stand together. So we need to get the arrangement of the 2 middle person, yung girl and then yung boy. So how many possible ways you can switch the girl and boy? You can switch it in how many ways? Or you can arrange that in how many ways? Okay, 2 factorial. Why is it? Why is it 2 factorial? Why is it 2 factorial? Because the other arrangement will be boy, 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 girl, girl, girl. So dalawang beses yung gitna. That's why you do have 2 factorial. Okay? And then for the girls, there are 3 factorial. Why is it 3? Because you can arrange girl 1, girl 2, girl 3 in 3 factorial ways. Pwede nandito si girl 3, nandito si girl 1, nandito si girl 2. So you do have 3 factorial ways. So same thing with boys. You can switch or you can arrange the 3 boys in 3 factorial ways. Okay? But since there's a condition that all the 3 girls stand together and all the 3 boys stand together, so you need to arrange also the middle persons. Okay? Yung girl and boy sa middle. So kung lahat ng boys nasa left, so a-adjust din si boys. Pupunta siya sa left. Okay? If lahat ng girls nasa right, okay, so pupunta din si girl sa right. So there are 2 ways that you can switch the middle person or simply 2 factorial. So therefore the answer is 72 ways. Okay? Do you understand? Can you figure it out, my dear people?
Yes, ma'am.
Okay, next. Next, so we're done with the first. So yeah, that would be permutation or row permutation. It's the first rule. The second one is permutation of n things. So the second rule is permutation of n things taken r at a time. So that will be n factorial, and in a permutation of n, take n r, so that will be n factorial over n minus r factorial. Okay? So the second rule, permutation of n things, take n r at a time. So that will be permutation of n, take n r, so that will be n factorial over n minus r factorial. So the example, 3 awards. So we have first, second, and then third. Will be given to 5 finalists in the beauty contest. Beauty contest or beauty pageant. If each finalist can receive at most one award, how many possible selections are there? 3 awards, first and second and third, will be given to 5 finalists in a beauty pageant if each finalist can be received at most 1. So the highest is 1. Okay, 1 award. How many possible selections are there? So using the second rule, okay, permutation of n things, taken r at a time, so that will be, what is your n here? What is your n? How many finalists that we have? How many finalists?
5.
5. So we need to, permutation of 5 taken. So 5 finalists, we need to take how many?
3.
3. Okay. So 5 taken 3. So that will be 5 factorial over 5 minus 3 factorial. So what will be the answer? 60 ways. Okay. So that's the second rule. Next. In how many ways can 6 children be seated in a row of 10 chairs and then 6 chairs? In how many ways can 6 children be seated in a row of 10 chairs and 6 chairs? So how do we answer letter A? 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 In how many ways can 6 children be seated in a row of 10 chairs? In a row of 10 chairs. So there are 10 chairs. Okay, there are given 6 children. So how do we answer it? 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 Can anyone answer it? How do we answer it? How do we answer it? Using the second rule. Using the second rule. Permutation of n taken r. So that will be 10 taken 6. And then the other one is 6 taken 6. So what would be the answer? What would be the answer? So there are 10 chairs. Okay? So sa 10 chairs, you need to take 6 students. 6 students. So what would be the answer? Hello? What would be the answer?
161,000.
Okay, 151. Next, what about the other one? What about the other one? 6 chairs, 6 students. So that would be 6 taken 6. So what would be the answer? What would be the answer?
Yung 720 po ba?
Okay, 720. Okay, 720. So using your calculator, you know how to use the calculator, right? You just press it. Yung NTR. Okay, permutation of n taken r. Next, another example. Let's say that given a president and a treasurer are to be chosen from a faculty club composed of 50 teachers. How many different choices are possible? If, okay, start with the first condition. There are no restrictions. There are no restrictions. So how do we answer it? A president and treasurer are to be chosen from a faculty club composed of 50 teachers. How many different choices are possible if there are no restriction? if there are no restriction? How do we answer this one? How do we answer this one if there's no restriction? What is your N? What is your N? Let me see N, how many? How many? How many teachers?
50.
Okay, 50. From the 50 teachers, we need to choose the president and then the treasurer. So your R is what?
2.
Okay, 2. So therefore, how do we answer it? How do we answer it? How do we answer it? N is 50, R is 2, so that will be 50 taken 2. Or permutation of 50 taken 2, so what will be the answer?
2,450.
Okay, 2,450 weights. Okay, 2,450 weights. Next, another condition. Another condition, so same problem this time. Pedro, one of the 50 teachers, will only serve if he is the president. How do we answer this one? How do we answer this? Pedro, one of the 50 teachers, will only serve if he is the president. How do we answer this one? Can anyone answer this one? So we do have case 1 and then case 2. Okay. Case 1 and then case 2. So what will be your case 1? Ano ba sabi ng problem? Pedro, one of the teachers, will only serve if he is the president. If he is the president. So how do we answer this? Anybody? How do we answer this? So case 1, so Pedro is the president, okay? Because according to the problem, Pedro, one of the teachers, will only serve if he is the president. So meaning, in case number 1, Pedro is already the president, okay? And then you have 49 ways to choose the treasurer, okay? Kasi na-shoot na ni Pedro, he's the president. So sa kanya na yung presidency, okay? What about the treasurer? What about the position of treasurer? Ilan yung possible choices in that manner?
49.
Okay, 49. 49 candidates for the treasurer. So we have 49 ways. Okay? 49 ways. That's case number 1. What about the case number 2? Case number 2, ano ba sabi sa problem? Pedro, one of the 50 teachers, will only serve if he's the president. What if Pedro is not the president? What if Pedro is not chosen to be the president? Do you think he will serve? Do you think he will serve?
Hindi po.
Okay. So what will be your case 2?
Is 49B kasi 49B po namin sa
Okay, that would be 49 taken 2. Am I right? Why is it 49 taken 2? Why is it 49 taken 2?
So, policy sa condition.
Okay. Because nag-refuse si Pedro. So there are 49 teachers that can be chosen to be the president and then the treasurer. So dun mo yan kukunin sa 49 teachers because nag-refuse si Pedro. Okay? Because according to the problem, Pedro will serve if and only if he is the president. Okay? So pag hindi siya naging presidente, he will not serve. So where do you get the president and then the treasurer? To the remaining 49 teachers. Okay? So 49 taken 2, what is the answer?
2,352.
Okay, 2,352. 2,352 weights. Okay? So therefore, what is the total?
2,401.
Okay, the total is 2,401 weights. Okay, 2,401 weights. Next. So same problem with the condition, letter C. Gandhi and Bliss, two of the 50 teachers, will serve together or not at all. Okay? Gani and Les, two of the 50 teacher will serve together or not at all. So you do have case 1 and then case 2. So what will be your case 1? What will be your case 1? Case 1 is serve together. And then case 2, not. So what will be your case 1? What will be your case 1? Serve together. What will be your case 1?
Is na occupy na ni Gani tsaka ni Leslie.
So what will be?
2.
Okay, 2. Very good. So yun, occupy na ni Gani at okay, hindi sila mag-serve pag hindi sila yung president and treasurer. So the treasurer and the president, we need to choose it in the 48 remaining teachers. That's why we do have 48 taken 2. Okay? So case 1, 2. And then not served, so 48 taken 2. How many?
2,256.
2,256. So what's the total? Total?
258.
2,250. 2,250. Okay? 2,258. Next rule, circular permutation. So we have third rule, circular permutation. What is circular permutation? What's the concept of circular permutation? If it's a circle, what's the concept? N minus 1 factorial. N minus 1 factorial. Why do we need to subtract 1? Why do we need to subtract 1? If it's a circular permutation. Why is there's a 1? What's the concept behind that? If it's circular.
May starting point.
Okay, merong starting point, merong reference point. Okay? Merong reference point. That's why we need to subtract it by 1. 1 representing the starting point or reference point. So for example, 8 students stand in a circle, putting their hands together in a team building activity. In how many ways can this be done if 3 of them insist on standing next to one another? Okay, so how do we answer this one? 8 students stand in a circle, putting their hands together in a team building activity. In how many ways can this be done if 3 of them insist on standing next to one another? How do we answer that? So there are 8 students. So 8 students. Okay. And then the 3 insist. Okay. The 3 insist on standing next to each other. So if the 3 insist on standing next to each other, you need to take it as 1. So how many na lang? 1, 2, 3, 4, 5, 6. So you do have 6 minus 1 factorial. Multiply it by what? Multiply it by what? Multiply it by 3 factorial. Why is it? Why do we need to multiply by 3 factorial?
Kasi yung group, pwedeng maalim.
Okay, because yung 3 who insisted on standing next to each other, you can arrange it. Okay, this one, yung 3, you can still arrange it. Okay, so that is 3 factorial arrangement. Okay, so we have 6 minus 1 factorial multiplied by 3 factorial. The question is, Miss, how do you get 3 factorial? Because the 3 who insisted in standing next to each other can be arranged also. Okay, what is important? That they are together, but you can arrange them in different position, or you can switch them in different position, okay, in different order. So what is the answer? What's the answer?
It's 720.
Okay, the answer is 720 days. 720 days. Okay? Next, fourth rule. the number of circular permutation of n different beads on a necklace or n key on a ring. N minus 1 factorial divided by 2. Why do we need to subtract by 2? Why do we need to divide it by 2? If we're talking about beads on a necklace and key on a ring. Why? Why is it over 2? If we're talking about beads on a necklace, it's still a circular permutation. Okay? But why do we need to divide it by 2? What's the concept behind that? Why do we need to divide it by 2? If we're talking about the beads and then the ring, or the key on a ring. If a circular permutation. If it is a circular form. But since we're talking about beads and then the ring, key on a ring, to solve that, that will be n minus 1 factorial over 2. The question is, Miss, why do we need to divide it by 2? What's the concept? Why do we need to divide it by 2? Because of what? Because of what? What's the reason?
Kasi wala kami, parang naalala ko dati. Ano, parang hindi siya mabaliktad.
Okay, flipping over.
Yes, sir.
Pwede kasi mag-flip, di ba?
Opo.
Okay, pwede mabaliktad, pwede mag-flip. So meaning, if that is the case, you need to divide it by 2. Kasi pwede mag-flip. Okay? That's why we need to divide it by 2. So for example, if the given is a necklace, beads on a necklace, or key on a ring. Okay? So pwedeng mabaliktad. That's why we need to divide it by 2. So we have n minus 1 over 2. N minus 1 factorial over 2. Okay? So for example, in how many different ways can 5 different beads and 4 different stones be placed on a string to make a bracelet. Okay? So kapag bracelet, pwedeng ma-flip. If the beads and stones must alternate. Okay? In how many different ways can 5 different beads and 4 different stones be placed on a string to make a bracelet if the beads and the stones must alternate? So how do we do that? So since it's a bracelet, pwedeng ma-flip, di ba? Flipping over. So therefore, we can use this one. N minus 1 factorial multiplied by, divided by 2. Okay? So therefore, that would be 5 beads. So 5 minus 1. Why is it? 5 minus 1 factorial multiplied by 4 factorial divided by 2. How do you come up with this? 5 minus 1 factorial multiplied by 4 factorial divided by 2. How do you come up with that? How do you come up with that? How do you come up with that? Ito. 5 minus 1 factorial multiplied by 4 factorial divided by 2. 5 minus 1 because dun sa 5 na beads, we need to determine the starting point. Am I right? The starting point. So we have 5 minus 1 factorial. And then the 4 stones, you can arrange it. You can switch it. Okay, you can switch it. For how many ways? 4 factorial ways. But since the given is a bracelet, pwede siyang na-flip, so you need to divide it by 2. So 5 minus 1 factorial multiplied by 4 factorial over 2. So therefore, what is the answer? So what is the answer?
288.
Okay, 288. 288. Okay, 288 ways. Next, the 5th rule. Distinguishable permutation. So we have distinguishable permutation of n objects when some are alike. So we have n factorial over n sub 1 factorial, n sub 2 factorial, up to n sub k factorial. So that's the 5th rule. Distinguishable permutation of n object when some are alike. Okay, for example, let's say how many distinguishable permutation of the letters are there in the word stat. In the word stat. So how many distinguishable permutation of the letters are there in the word stat? So first you need to count how many letters do we have. So there are 6 letters. Okay. You need to divide it. How many S? There are 1 S. So that will be 1 factorial. There are 2 T. So you do have 2 factorial. And then 1 A. So 1 factorial. So what will be the answer? Or the same as 6 factorial over 2 factorial because 1 factorial is 1. Okay? So what will be the answer?
360.
1, 2, 3, 4. There are 4 letters. So there are 4 letters. 1, 2, 3, 4. So 1, 2, 3, 4. So 4 letters. So what will be the answer? So there are 4 letters. 12. Okay, so there are 12. Okay, so first you need to count the number of letters. So there are 4 letters. Okay, so there are 12 distinguishable ways. Okay, next. How many different signal lights can be made with 6 colored bulbs arranged in a row with a set of 3 indistinguishable green bulbs, 2 indistinguishable red, and then yellow. Okay. So how many different signal lights can be made with 6 colored bulbs arranged in a row with a set of 3 indistinguishable green bulbs, 2 indistinguishable red bulbs, and then yellow? So how do we solve that? First, how many bulbs that we have? How many bulbs that we have?
6.
Okay, 6 bulbs. So there are 6 bulbs. Okay. So 6 factorial over how many green?
3.
Okay, 3 factorial. How many red?
2.
Okay, 2. How many yellow? 1. So therefore, what is the answer?
60.
The answer is 60.
60.
60 ways. Okay, 60 ways. Next, partition. So what is partition? Partition of a set is a collection of mutually exclusive disjoint subsets of the set whose union is the set itself. Okay? So we do have partitioning formula. So that will be n factorial over n sub 1 factorial, n sub 2 factorial up to nk factorial. So that is partitioning formula. So for example, okay, so we do a partition. 8 toys will be distributed to 3 children with the girl getting 4 toys, and each of the 2 boys getting 2 toys. So how do we solve it using partition? Okay, to solve it using partition, so there are 8 toys. So 8 factorial, you need to divide the 8 toys with the 3 children. So we have girl, boy, and then boy. For the girl, she will be getting how many toys? She will be getting how many toys?
4.
Okay, 4 toys. What about for the 2 boys? How many each for the 2 boys? How many each for the 2 boys? Okay, 2. 2 each. So the first boy, 2 toys. So that will be 2 factorial. And then the second boy, another 2 toys. So that will be 2 factorials. So that is partitioning. Okay? So what will be the answer? What will be the answer?
840.
What will be the answer?
Medyo.
What will be the answer?
420.
Okay, 420. Okay, 420. So we will continue our discussion on Monday. Our next will be combination. Okay. Our next will be combination. But before we end our session, can anyone answer this one? In how many ways can 5 teachers be accommodated in 3 hotel rooms? 5 teachers be accommodated in 3 hotel rooms, where 1 is a private room, and then the others are room for 2. In how many ways can 5 teachers be accommodated in 3 hotel rooms, where 1 is a private room, and then the others are room for 2. So how do we answer this? 5 teachers, there are 3 rooms. Yung first room, private room. And then the other rooms are good for 2. So how do we answer it? Using partition. How do we answer it? Using partition. How do we answer it using partition? How many teachers do we have?
5 po.
Okay, 5. So 5 factorial over what? Over what? 5 teachers eh. So 5 factorial over, sa first room, ilan yung pwede?
5.
3 rooms lang 3 rooms. So first room, private room lang, so isa lang pwede. And then the remaining rooms, yung dalawang natitirang rooms, good for 2. So ilang teacher yung possible dun sa dalawang rooms? Eh, good for 2. So in the second room, dalawang teacher. The third room, another teacher. Okay, another 2 teachers. Since it is good for 2. So therefore, what is the answer? Therefore, the answer is 30 ways. Okay, 30 ways. So we will continue our discussion on Monday regarding combination. Okay, so